Hello everyone, I welcome you all for day 10 of our training program. Yesterday we were doing a project based upon AI impact on students. We took a data set in which the parameters available were related to academics, mental health, institution, etc. We started our analysis, and in our analysis we found, as mentioned in the data set, that it doesn't have any duplicates, it doesn't have any null values present. Well, such kind of data set are less available in the real world scenario, or I would say in industry where you are having least possibility duplicates, null values, or any kind of cleaning require in a data set. You always get a challenging data set, and like based upon it I have explained what could be the situations can come in front of you while handling a raw data set, especially duplicate that's easy, null values that is something challenging. And apart from that, you may require to clean the data in different perspectives. We proceeded analyzing the data set, and we made the plots univariate bivariate analysis we have performed. I told that you need to make a box plot and scatter plot, count plot, all such kind of plots as expected. For example, categorical and discrete, you need to make count plot, pie plot in univariate analysis. While for continuous features, you need to make scatter plot, line plot, while doing bivariate analysis. That means continuous versus continuous. Here is the summary, and you should remember while doing the analysis. The kind of plots were count plot, pie plot. I haven't made, but I told you that you should. Histogram, dist plot, box plot, Wallin plot, Boxen plot, all these plots will be made under univariate analysis. That means for only one variable. And these two are for categorical and discrete features. Rest all of these are for continuous features. Remember this thing. Okay. Next, for bivariate analysis, you need to make bar plot, box plot, that should be between categorical versus continuous, or discrete versus continuous, where these features should be on x axis and these features will be present on y axis. Got it. Then you can make a line plot or scatter plot. This should be between continuous versus continuous. Okay, so what we are trying to find from here is relationship between the variables and how they behave, what their distribution is. If we understand, then we can do interpretation regarding any like if you want to apply some orientation in this, or we want to like drop any of the feature based upon correlation, whatever be the necessary steps we need to take, we will be taking based upon the distribution of the features. Okay, at last I have made a correlation or heat map also, that was showing relationship between numerical features. That's what you have seen. Okay, here also features were present. Here also same features were present. So like we were showing the relationship between the features, and I also marked that that some features will be having high correlationship, as we have seen yesterday, more than 80% or 90%. Some of the features will be having very less correlation, zero point 0.0 something. Some features will be having intermediate correlation, 20% or 30%. Some may have a relationship like 50% or 60%. It can be negative, it can be positive. Positive correlation means if one feature is increasing, another feature is also increasing. Negative means inverse. One feature is increasing, another is decreasing, but they are correlated with each other. Okay, so this correlation, this heat map is very much important. All right, so let me share my entire screen. Till here, we have already performed. Meanwhile, I have been also asked, sir, if we are working on a local machine, then what to be done? Here you are demonstrating on Kaggle, but let's say we are working on a local machine, then what to do? Let's say I am working on a Jupyter notebook. This is my Jupyter notebook. Okay, got it. So in this Jupyter notebook, what I can do is, first of all, let us understand the path from where this Jupyter notebook. That's mandatory. Okay, that's mandatory. I should be knowing the path from where accessing this Jupyter notebook. I have installed my Python, my this Jupyter notebook in D drive. You can see this is my D drive. You do also have the installation in some drive, C drive or whatever. I just want to suggest you something which you should keep in mind, and it is very much important. How to do the installation? Very much important. Well, if you install Python, okay, if you install Python, there is obviously official website of Python. You kindly install the Python, download it, and then run it on your machine. What kind of platform you are available with? Currently, I am teaching you like I do have Windows platform. Okay, so like download that exe file and install it before you do simple work in C drive. In a C drive, make a folder Python. So I expect a custom installation. You install the Python in this folder only. Because if you install, it will give some path from its own side. Don't select that path. Kindly create a folder Python in C drive and do all the installations here only. Okay, because at the end you get frustrated. I am not getting the path from where I need to open the Python, from where or where to put my data, how to access the data. There are so many complications happens with the students. That's what I know. So keep the things easy. C drive, make a folder Python and install all the packages files here only. After that, what you need to do, you open the command prompt. Okay, command prompt. And in command prompt, you go to C drive, go to Python, and here you can install Jupyter Notebook. Pip install Jupyter Notebook. Okay, or you will be writing pip install notebook. Pip install notebook. So your Jupyter Notebook will be installed here in this path. Python, inside Python, notebook will be installed. Some people do work on Anaconda, PyCharm, etc. So there are so many other applications you work, but I haven't, I don't work such frameworks or such applications. I either work on Kaggle, either I work on Google Colab if it is required for some kind of task, or else I work on local. Like my Jupyter notebook, and this is how I have installed. So I'm suggesting you my way. Okay. So what I told, C in Python, this directory you are present, right? Pip install notebook. Once your notebook has been installed, then you do one thing: close command prompt. Okay. Open the then afterwards open the command prompt again. Open command prompt again. Go to the path C Python, and then here write Jupyter Notebook. Jupyter Notebook. After you will write Jupyter Notebook here, your notebook will open. It will look like this. The notebook will get open and it will look like this. Home page. This is the home. Local host. It will look like this. It's loading. All right. And if you want to create a new code, then new, you can open IPY kernel and create a new file, do the coding, and that will be saved. You can give a name to that. Similarly, that's what I did here. You can see AI Impact Student Project. All right, so this is the way you can do the code. And one important step, because you need to access the data in this particular file. In Kaggle, you access the data like this way. You have given the entire path where a data set is present. All right, entire path was presented by you. Okay, here what you need to do, your data set, AI student impact data set, this data set should be present in a Python folder. So this is my Python folder. This is my Python folder, and any data set, whether CSV file, whether images, whether text, whatsoever you are doing, kindly put all of them in this folder only. Then it's easy for you to access. So I have explained you the easiest way how to install, how to access, and where to put the data. Okay, so all my data sets are present in this folder only. Got it? If that's the case, you can directly access the data set. All right. So this is the file which I have created on Jupyter Notebook, but I don't need all such things. I only require NumPy and Pandas. Control C, and let me put it here. Add a new cell, and NumPy Pandas. Let me run this thing. I don't require this Kaggle and all. Delete. Okay, NumPy and Pandas. That's what I'm doing. Okay, got it. Fine. Then my CSV file. It's not present in Kaggle input. No, no, no. Delete all. Delete this till here. Delete. And just this much is required. Read underscore CSV AI student impact data. This is the AI student impact data. All right. This is the data set, which I have downloaded on Kaggle from Kaggle, and I have saved file save as in Python with the name AI student impact data. So, CSV comma delimited. Okay, so remember this thing. All right, it's already saved, so I'm just canceling. Fine. Now you can access the data. So this is my DF, and here I'm printing the DF. All right, got it. So, I got one query that, sir, kindly let me know that if I'm working on local machine apart from the Kaggle, so what can I do? I have gave the guidance that what should you do. This is how you can install the Python, and if it's already installed, you already know the path where actually the Python is installed. So kindly put the data set in that particular location, and whatever be the rest of the code, it will be same. The rest of the code will be same as we were doing the last day. So I require, I need everyone that till correlation we have performed. This was the last code. Okay, correlation we have already
Hello,
performed.
hello,
Okay, yeah, please say. Any doubt, please
sir.
let me know.
Yes, sir. So based on the external code, I have two question.
Huh?
My first question is: suppose my target feature itself as a 50% nan
Target
value.
is.
Target variable.
Huh?
Target
Huh?
variable is itself as a 50% nan variable. Now, in this case, can you do the same imputation either mean, median, mode, or you can make another feature column as a target variable? This is my first question.
Well,
And
target variable as per the data set, like I have described, there are three targets which you can keep from your side. Okay, as per in the data set, they mentioned three targets you can keep. Okay, so currently we are taking the target as a GPA. Okay, you can do the analysis by taking that as a target. Okay, and it's a regression problem because that this GPA is continuous in nature, that these are the marks. Okay, so it is continuous in nature. All right, so we are proceeding ahead with this particular target. Next, you can work on taking a target which is categorical in nature. Okay, for classification problem. So currently we are dealing with a regression problem.
but a target variable is also contain nan value more than 50%.
Target variable itself contains null values 50%. What
Yes,
you are saying?
more than 50%. Ha.
Okay, more than
Then,
50% target, if
ha,
that's the case. All right, fine.
yes.
So ultimately, if the target is itself is having more than 50% values which are empty, what can be done in this case? 50% null value in target only. And if I fill this 50% of the null values, let's say your current target is continuous in nature. So you have two options: either you are going to fill it with mean, or either you are going to fill it with the median. That these are the two options available with you. Well, we can fill them we can fill them with either of these values. Depends the orientation of the target which we have identified with the histogram or with the distribution plot. Okay, last day, as I told, we can fill these. Or if you think that my data set is very huge, it is having 1 lakh rows present in it, and 50% is empty. I am having 50,000 entries present which are filled. 50% are empty, 50% are filled. So you do one thing: you can perform drop NA. That will be dropping 50% of the rows, and you will be available with original 50,000 which are filled. All right, that's the one of a step you can take, rather than filling the null values with mean or median, because mean and median will be obviously pre-calculated value. I am here not mentioning or suggesting you that drop the target itself. If you're dropping the target, then what's the calculation you want or you can do? Okay, we are trying to find the solution for the target which is having 50% null value. So if I will be there, I have the choice of filling, or if the data set is very huge, then I have a choice that I can work with 50% only without filling. Okay, and try to find the
So
insights from this
in
50%.
this case, can you do the another feature as a target variable? Is it possible?
Well, any other target, if you are expected to take apart from this, that's what you are saying.
Yes, yes.
That's what you are saying, or you
Yes, I am saying that if target variable itself
huh
50% NaN
huh
value,
huh
so even I am filling this target variable as a mean and median,
huh
sometime it will be model overfits. So
huh.
in this case, can you drop, not dropping, can you make another
Well,
feature
it
column as a
depends. Your
target
problem
variable?
statement will be solved with by that or not. If your problem statement is not being solved by taking another feature, then what to do? Okay, you need to solve your problem statement. If you think that, sir, this is not a good idea. 50% more is there. Drop it and take new target. Okay, take new target, but your problem statement should be solved by taking the new target. If it is
Okay,
not
okay.
solved, then kindly follow this approach only. One more thing: if you are having very less data, for example, 5,000, only 5,000 rows available with you, and 50% of the target is empty. 50% of the target is empty. Well, we always try to keep target filled. That is what my suggestion is, because all this data is collected. There is a process we first perform. That's a raw collection of the data. Okay, and for the raw collection of data, we may have features can be empty. Okay, but our target, like we expect that it should have the values. Okay, so if you have collected a data set where your target is 50% empty, that means you haven't done a fair work. Okay, do the revision properly. You haven't done the fair work. 50% you made empty only, and what kind of data you collected? But certainly it may happen that you are not available. Then you have a choice: either fill it. Let's say if you are having 5,000, 50% is empty, then there is no chance of dropping 50%. Okay, because here we don't have 50,000 to analyze. We will be having
Sir,
2,500.
any question?
All right, so fill it. Fill the target with me. Proceed.
Okay, Keshwan, sir.
All right, got it. So let me do one thing. This is the last notebook which we have left. I will be doing edit. Let us click on the edit part, and in the edit again go to the session options, click on accelerator, turn on the GPU. Okay, and run all. Okay, here is the option run
Sir,
all.
Keshwan, sir.
Hmm.
Keshwan.
Are you able to hear me?
Why, Keshwan, sir? Can we predict multiple target variables?
Yes, we can predict multiple variables also. Multiple targets can be there. That is also possible. That is also possible.
Okay, possible. Okay,
Multiple
thank you,
target
thank you.
prediction. That is possible.
Yeah, in data health center. Another concept.
Okay, there is a voice at your end. I can't hear properly. So the question came that can we predict multiple targets also? So answer is yes. There could be multiple prediction. Never expect that you are only having a y as a target, where let's say you are predicting house price. No, you can have y1 also, you can have y2 also. there could be multiple protections, multiple targets. Got it? Well, I was editing my notebook. Here it is. I request everyone to do run all and reach till here, which we have achieved on the last day, till correlation heat map. Till correlation heat map. I request everyone to run. All right, running at your end. Yes, you are running the code. Please run all the cells. Like you can just click run all. It will automatically run. I'm waiting for the session to get started. It will start, and all the cells will be executed. Okay, session started. All right, cells are executing. At here, and also please check, because we are now at a stage to apply a model. Before that, I want to tell you some important steps which is required. Here is the execution of my code. Okay, it will be done. I'm already available with the code which is executed. So let me share you that part, and you continue coding while I will explain. Till here we have done. This is pair plot. Okay, fine. Let me exclude it. Second thing is I want to give you an understanding. Kindly run this code once your code is completely executed. That means till here, if you have reached, till here if you have reached the last day which we have done, na? Correlation heat map, till here you have reached, please run this code, this part of the code. This code is for outlier detection. This code is for outlier detection. Okay. Uh, I need to find the outliers or wrong or faulty entries present in the data set. Got it. So what I am going to do is I am considering all the numerical columns, and I am calculating Q1, I am calculating Q3, I am calculating IQR, that is interquartile range. Okay, so Q1 25%, Q3 75%, Q3 minus Q1 is that range between which this Q1 and Q3 are present. And here is a formula: lower value calculation and upper value calculation. Okay, so the lower value, the cutoff value, lower cutoff value will be Q1 minus 1.5 into IQR. This is called as 1.5 rule or Turkish rule. Okay, it's a rule. We can calculate the lower value till which we can accommodate our distribution of the data. That's given as Q1 minus 1.5 into IQR. And the maximum value which we can accommodate, or upper value, is Q3 plus 1.5 into IQR. Got it? So any value which is lower than, any value in the data frame, numerical values, which is lower than Q1 minus 1.5 into IQR, this one will be considered as an outlier, and any value which is greater than the upper will be considered as an outlier. So like you are marking the upper and the lower values from here. All right, rest of them will be outliers. That's what I'm trying to identify, and I got the result as there are 2583 values present in weekly Gen AI hours which are outliers. So nearly 5% of the values are outlier, considered as an outlier according to statistical analysis, that these are wrong or faulty entries according to stats. That's what they are saying. Everyone reach till here, please let me know. Everyone reached till here? Please let me know. Yes. All right. So, like, it shows the counting of the
Hello.
outliers. Yes.
Sir, imputation can be done before the outlier removal or after outlier removal.
Again, a very important question. When can we do the imputation? And I request everyone to be present because such questions are very technical and very important. Being as a data scientist. Well, before imputation, I told that if you have a feature which is having null values, so you are making a plot for it. You are making a plot for it. Okay. And if the plot is like this, or if the plot is like this, that means it comprises of outliers. It comprises of outliers. Since the values are null values, it has been suggested to you that there are so many outliers present in it. Kindly fill with median. Kindly fill with median. So in general context, if I would say, we fill first, because median is less impacted by outlier. Okay, median is less impacted by outlier. So if you do have outlier present in your data set, so fill with median and then remove the outlier. The impact of outlier will be less on it. However, if you do not have outlier or very less outliers present in your data set, then obviously you are going to fill with a mean and proceed. That is what I will be saying. Therefore, you might have seen in the codes also, people do impute first by checking the distribution of the data. They perform the imputations. All right, but check and then perform the imputation. Later on, you can remove the outlier because you have already filled with the median. Now, less problem will be there. Got it? Here I have identified in my code. In my code, I have identified that 5% outlier is in one column, rest they do not have that much outliers. 0.69, 0.66. Okay. So they don't have much impact. We are not going to drop any of the outlier, we are going to keep it with us in our data set. Your next code is if we analyze these features. If we analyze these features, I'm again putting in the comment section. Please run the code. Please run this code. If you analyze these features, like weekly Gen AI hours, pre-semester GPA, post-semester GPA, traditional study, skill retention. Okay, this is what we are getting. Already we have seen in df.describe, but separately we are describing these columns. Statistical analysis we are doing. All right, minimum value, maximum value, median, standard deviation, mean, like these things. Okay, median is 50%. All right, so we are just analyzing, describing these values, writing the statistical information about them. Okay, so what I decided is we are not going to drop anything from our data set. 5% and like consider. Okay, proceed ahead. Now, one more step we do after EDA and this outlier and all these things. Now, feature engineering. Feature engineering. In feature engineering, we create new features from the existing features. So let me paste the code for you where we have created new features from the existing features. Okay, that's called as feature engineering, and it is again a very important step in our data science and machine learning, creating new features from existing features. All right, what I did, you can check. GPA improvement, post minus pre semester, Gen A study ratio, weekly divided by traditional. Okay, so weekly Gen AI usage divided by non GI usage. That is study ratio, Gen AI study ratio. Then total learning hours, weekly Gen AI hours minus traditional study plus traditional hours. So total study hours. How many learning hours are there? AI usage intensity, that is weekly Gen AI hours multiplied by tool diversity. How many tools, how different tools you are using, and what are the hours of usage overall. So that is AI usage intensity. Then learning efficiency, skill retention divided by total learning plus one. That is learning efficiency. Okay, one more new feature. Then GPA gain percentage, post semester minus pre semester divided by pre semester multiplied by 100. This is GPA gain percentage. Okay, then dependence anxiety index, perceived AI multiplied by problem or anxiety in the exams. So this is the dependency on AI, anxiety index. That is also you can calculate. Then burnout map, like we do have low, medium, high. We are giving them as one, two, three. Label encoding we are doing. Okay, got it. One more thing, prompt skill score. That is prompt engineering. We are again giving as one, two, three. Label encoding or just mapping them by one, two, three. Okay, academic performance. We can take a post semester low, medium, high, like this way. So 0 will be low, 2.5 till then again 3.2 will be medium and 4 will be high. Okay, heavy AI user, Gen AI hours greater than weekly Gen AI hours median. So we are going to get a person which is heavily using AI. Okay, retention level, skill retention score, low, medium, high. We can assign between which range to which range we can have low. So for example, 0 to 60 is low, 60 to 80 is medium, and 80 to 100 is high. Skill retention score, that is retention level. That's also we can decide. AI engagement score, so like multiply with weekly Gen AI hours, multiply by tool diversity, multiply by perceived AI dependence. It depends how much fraction you are going to keep. So total is one fraction, so 40% weekly, 30% tool, 30% perceived. So all these features I have made. These are the list of new features, and I hope you have also displayed the list of new features. Total 15 new features are created. Okay, total 15 new features are created. Now next, after feature engineering, you can proceed ahead for next thing, next important thing. Now listen to me carefully. What you have done so far, what you have done so far. The steps of data science or machine learning are: step number one, data collection. Okay, you haven't done, you are already available with the data set. So in every research paper also you need to mark this thing. In research paper also you need to write from where you have collected the data. What is the source of the data? All right, so mostly I just mentioned from Kaggle I took the data, or from any authentic website I have taken the data. These are my data sets from where I have collected the data. Okay, you have performed data pre-processing, pre-processing. Okay, or I would say cleaning. You have performed EDA. Sometimes it happen in exploratory data analysis. They include visualization also. Okay, in EDA, visualization is also included, and if you want to separate it. Not, I don't mind this thing. Exploratory data analysis, visualization. All right. Then fourth one, what you did, outlier detection and removal. Okay, so like in pre-processing cleaning, remember duplicates, null values, all this you have cleaned, or any other kind of cleaning requires, then done. Okay, step number four, outlier detection and the removal. Then step number five, feature engineering. Feature engineering you have done, created new features. Now step number six, what I'm doing is relationship of features with the target and among themselves. This is what I want. Why See, I just want to clarify. Initially you were having 16 features. ID feature you had dropped, then you are left with 15 features. In 15 you are having one target, so 14 plus 1. Okay, 14 plus 1. And with feature engineering you have created 15 more, so total will be 29 plus 1. So 30 features. One thing I just want to remind again, we never train a model with many features, because like these features will be correlated with each other. They will show overfitting in the model, because there is a problem in machine learning. The problem is called as curse of dimensionality. Curse of dimensionality. That is the problem. So if you do have multiple features present with you, okay, in that particular case, you will be facing a problem of curse of dimensionality. All right, it will show overfitting in the model. Therefore, we require only specific features to get trained, over which my model should getting trained. So, what those specific features are? What will be? In order to find that, we need to we need to we need to perform and correlation analysis. All right, and here is the code for it. Here is the code for it. Let me put the code. You please run. Okay. From here, the correlation will be clear. Kindly run this code. Correlation analysis. Got it. In this code, what I'm doing is, I created a copy of my original data frame. Then I'm ought to find correlation between the features among themselves, not with the target. That means among themselves, and displaying their absolute values of correlation. That means negative correlation, don't mind, take all as positive. And here I'm making a data frame, and I'm just arranging them in ascending order. False, that means descending order, highest to lowest correlation. So obviously pre-semester GPA will be having its highest correlation with itself only, it's a target. Anyways, GPA improvement category. Okay, all this correlation been present, and like here you can see feature correlation between each of them with a value is mentioned,
Sir, question.
how much it
Question.
gained. Okay, any doubt? I guess you want to ask anything. Can you please
Sir,
I'm
question.
unable to
Question.
yeah, I'm unable to hear what you are saying.
Hello, sir.
Yes, please say.
Question.
Yes,
Okay.
now
Thank,
and I can hear you.
okay, thank you. My question in the
अभी you are
Can classify linear learning or logistical
guess
regression
you are
with
some
this
having issue with your mic.
set
Can you type your you can type
predictive
in the
behavior.
comment section your problem. I will respond. You can type your problem. I'll respond.
Correlation with itself, what it means?
Yes.
Your correlation with itself, what it means here?
Correlation with itself. No, correlation with itself in general, na, correlation with itself is marked as 100% related, and they are present in the diagonal values. So correlation with itself is not the sense. Correlation with itself is not the sense. Okay. What we are expecting here is the target. Okay, here is the target. I created a copy of my data frame, and then next, what I did, you can see column in correlation select object and categorical columns, object columns and category columns. Okay, object columns and only categorical columns, not numerical columns. Create those or identify those as my columns of interest, marked as df underscore corr. That will be my columns, and here I'm going to mark the correlation, and that will be numerical only. Now here I'm going to make a new data frame correlation underscore df, and here will be the features which I identified from above, which are object and category, and here I'm going to find the correlation of these features with numerical only, and I'm just considering the target. This one is the target, post semester GPA. This is the target. Okay. Now, if you want to do it more perfectly, and if you have anything, you can do print one step by one step. Let me suggest. Let me suggest. Take this as a code I have given you all, but do one thing. Kindly print them one by one. Do like this. That will help you in understanding what features are coming. DFCOR, it's already a copy of DF. Now, what you are going to do, print corr underscore df. Just first do this thing. Rest I'm ignoring from here. Control C. Let me remove from here. Okay. Let me run this code. What it's coming? Here it is. You can see. You can check. You can check. In fact, like what I got. See, feature and correlation. Correlation with whom? With whom I'm finding the correlation? With the target. So major category having a correlation with the target is 0.005. Year of the study having correlation with the target minus zero point zero 0.02. Pre-semester CGPA having a correlation with the target is 0.9. This is very good correlation. And we have already found that pre and post CGPA or GPR are same only. Nearly same. So the question has been asked, sir, why we are doing between, this is not same to same. Okay, don't get confused. These two things are written. No. This is this is your feature, and its correlation with the target, which is post semester GPA, that's been displayed. Okay, don't get confused. Okay, so pre semester
Okay, sir.
GPA correlated with the target is 0.92. GPA with 0.27, improvement category with 0.24. So that is how we have arranged them in descending order. Those features which are least correlated with the target, we don't expect them to be present in the, like because if they are least related with the target, they are not going to contribute in the prediction of the target, obviously, because they are not related na. And one more thing I just want to clarify. At least we want a 5% of correlation, at least. If they're not 5% correlated also, then what the sense of keeping them? What the sense of keeping them? You are doing the prediction and your target and features are not correlated, and what kind of equation is going to help you in predicting? That is why I'm finding the features which are good and which are having good that means high variance, and also good in a relation with the target. So I got these features: pre-semester GPA improvement category. These are 20%, some is 9%, 6%, 6%, 4%. Burnout risk level, from rest these are 4% and less than, very very less. What I'm going to do next, I am selecting few features from above. Control C, and let me put it here in the comment section, and we are going to train our model based upon them. Okay, here are the few features which are identified. Okay, these are the few features which are identified. Kindly run this code. These are the few features which are identified and good for our assessment. So pre-semester, weekly GNAI, and all these. Out of this, one more thing you should consider, according to my suggestion. Listen carefully. Pre-semester is exactly the same as post-semester. Check above correlation metrics. Correlation metrics. Check here. This is post semester GPA. That is our target, and 93% pre semester is associated with it. So, according to my suggestion, though I have included pre semester GPA, but I request you to drop pre semester. I request you to drop pre semester. All right. So again, let me get out here in this cell. Okay, in this cell. Yeah, here. Please remove pre-semester GPA from the list. All of the people, kindly remove pre-semester GPA from the list. So let me share it again. Control C, and let me put it here in my notebook. Control V. I am removing pre-semester GPA because it is highly correlated with the target, and it will show the overfitting in the model. Only these features will be good. Good. Also, one more thing I want to tell. Weekly GNI hours is 67% correlated with the target. Highly correlation. But I need to keep them. I need to keep them. Okay, below 75% keep. Rest of them are fine. All right. So let me again copy and paste in the comment section. You consider these features only. These are your new features which you need to consider. I removed one feature. Next, here you can take X and Y training. We are going to perform it. First, take training features and what is the target one. So let me put it here in the comment section. Please run this code. You're getting X and Y. Okay, these are X and Y. Now, what next you can do is you can perform label encoding of the categorical columns. Control C. Again, I'm putting in the comment section. Kindly do the label encoding of the categorical columns. Kindly run this code. Label encoding of the categorical columns. Okay, perform this thing. As you have seen above, 1, 2, 3, this, they will be numbered. Okay, and then perform here train test split. Control C, and Control V. I'm putting here. And please let me know, have you reached
Hello, sir.
this point?
Excuse me, sir.
Yeah, please.
Feature engineering part, we did not do it, I think.
Feature engineering you haven't performed?
We did not do. You did it, huh?
Huh?
Mhm.
Okay, you haven't performed. I haven't copy pasted that particular code.
Yeah, from that,
I haven't copy pasted that particular code. Okay, let me do it.
yes. Once
All
you
right.
can check.
Okay. Feature engineering. Let me copy paste. This is the feature engineering entire notebook. Okay, this cell. Let me put it. This is feature engineering. Control C. Let me put it. All right. If you haven't done, let me give you the entire flow. I hope you did till here. Till here,
Hello, sir.
perform outlier detection. You have done. Okay. This you have done. Then feature engineering. After feature engineering, take the target, find the correlation. I guess this code is available with you, and finally, just remove pre-semester. Now, any doubt? Please let me know.
Sir, I have a question.
Yeah, please say.
Sir, you said that if two features are highly correlated, then we can drop one of the feature,
Yes,
right? So this
yes.
process we can do before the feature creation or after the feature creation?
Before the feature creation, or
After the feature creation
see,
for the new feature creation.
uh, feature engineering is done before what? Your
Uh,
training. Okay,
drop.
before you
No,
want
no.
to train the model, this train test split you want to do that, you create the features. All right, got it. So, like what I did, created the new features, identified the correlation with the target of all the features which I have created, and then I am doing the removal of the feature which are related, and then I'm putting it into the training part. What procedure I followed, I request you to follow the same procedure. Okay, because it means like if you say, sir, like we have removed some features, we identified the correlation with the target with the existing features. Okay, and then we have removed those features which are least correlated with the target, we have removed, and then now you do feature engineering with the existing features. So in case those we have dropped, if you do analysis on them, we might get some information in analysis. Why to lose them? If you see again my notebook, we got some good information, like let's say, uh, heavy AI user. Okay, then dependency anxiety. Okay, learning efficiency. So we got some good features which we can drop lots, or which we can inform to our clients. Okay, they are not related to the target, fine. Okay, maybe they will show less correlation on the target, but at least create them, might be helpful ahead for any kind of information. All right, so do this thing, then find the correlation, then drop. That will be happy time. Understood? Understood? My perspective, you understood what I'm trying to say. And if you already dropped them prior, then anything if new will be created, I'm not in the position to do any kind of analysis over it. You understood my point, what I'm trying to say?
Yes, sir. Yes.
Okay, so you may get different suggestion from different people, but what I understood is I haven't dropped those features. That is why I'm in a position to create new feature from them, which may show some information. Doesn't matter, they are not reliable to me ahead. I will be dropping. That don't harm me, because at the end I'm going to use only those features which are good for my target. All right. So I hope you reached X and Y, label encoding you had done, train test splitting you had done, and yeah, numerical features you need to scale. Yes, take this thing also. Numerical features you need to scale. Standard scaler. Take this code and numerical feature scaling is mandatory. Standard scaler. So categorical feature you convert them into label encoding. Numerical feature you perform standard scaler. Got it? Okay, now next check what you are going to do. Here it is. Now I am applying linear regression. Control C, Control V, and please let me know how much scores you are getting. I'm waiting for your response.
Hello, sir.
Yeah, please say.
Sir, if you create a new feature from old feature
Hmm.
and we are getting a good result from new feature,
Hmm.
So should we preserve the old feature or
Preserve.
should we drop the old
Sir,
feature?
sir, one more thing. Since you have created new from old, then there might happen that new and old will show high correlation because they are, this one is created from this only, and if this is present in the list and new is also present in the list, then obviously they will show correlation, high correlation. Our concern should be to keep any one, because what I told you, features should be least dependent among each other, least dependent among each other, but they should be good related with the target. So sir, if they are related among each other, problem, either take new one if it is more informative, good relation with the target, or either take old.
Okay, sir. Thank you.
All right. Else will be again problem of overfitting. So can you please let me know how much score you got with this? What is the R2 MAE? How much? Using linear regression. Anyone got how much? What's the R2 score? What is the MSC? What is MAE for linear regression? Please let me know. How much? At my end, it is 0.88, and that's also because of the presence of pre GPA. But I'm not considering pre GPA now. Now let please clear me how much you got. Yes, what's the score? Okay, MAE 0.39, MSC 0.22, RMSC 0.47, R2 is 0.05. ISEC. R2, that means variance explained is very less. Only 5% of the variance is explained by your model linear regression. ISEC, that's what you got. However, errors which you are showing is less. 0.22 and 0.39 and 0.47 error is less, but variance explained, errors is less. Okay, it's now it's like it's your will, you will go ahead with RMSC or MSC as your primary metric to defend your model. But if you take R2 score, then that is not suggested, because R2 score is only 5%. 5% variance is explained by your model. That is not something suggested. What about others? How much? Other people? How much? And I will also explain you what could be the possible solution. Other people, how much is the score? Is I printed the scores? I request other people also to show the score what you achieved. And that's pretty much clear why I got 88, because pre GP is present in my code and my model shows overfitting. This is overfitting. Why overfitting? Because because my model captured the points of pre GPA, and pre GPA is close to post GPA, because both are 93% correlated. So my model didn't learn, my model memorized. That's the reason for overfitting. Now other people, error getting, why madam? If you're running the code, if you're taking the blocks correct, then there should not be any error. Why you're getting the error? Okay, Mr. Venkat is also saying that you got the error. Why? There should not be any errors. Okay, here is my notebook. If you want, let me run my notebook. Okay, let me run my notebook. Deleting this thing. Okay, let me delete this thing also. Fine. Let me run my entire script. Shape, columns, drop, duplicates, delete or drop. Okay, let me do run all cells. Okay, after running all the cells, what I'm getting, I'll show you. It will take a bit time for the execution here. This current notebook session is starting, but it will get started. Anyways, till correlation, I have already demonstrated. You also did. Now, after correlation, pair plot, I don't need. Outlier also, we are not considering. Okay, then new features we created. So let me put it here in my notebook. New features. Control C. Let me put the new features here. Okay, it will take a bit time for the CPU. All right. Okay, it will take a bit time. Then everything will be executed. Here are the new features. And after creating the new features, I find the correlation. Let me pick up the correlation also. This code of features with the target. All right, let me put it here. Let me run. Okay, so after all these plots will be done, my code will be automatically taking the rest of the cells. After that, we have identified the correlation. Then Control C. Those who are getting the error, na, kindly run all again. It may happen that you did some mistakes. Okay, then here it is, removing the pre-semester GPA. I don't want to consider pre-semester GPA. Okay, let me run this code. Okay, and then X and Y, Control C, Control V, taking X and Y features, and then doing label encoding. Okay, and then doing standard scalar train test split. That's what I need to perform. Let me check that also. Okay, this one, standard scalar, done. Standard scalar, and then putting it into the model for linear regression. Let's see what I got. All right, I also got the same thing what ISEC got, 5% R2. Rest errors are less. That means points are present near to the regression line, but they are not actually coming over the line. Variance is not explained. Now, tell me if anyone is having like problems or like are you recording the class? Yes, I am. Now, okay. Shanu, Dr. Shanu ma'am got R2 same. I guess everyone is. I am also getting the same. Everyone is getting the same results. Okay, Isaac, you got 88% afterwards. How? If you are taking the features, that means that pre GPA, then obviously will get 88. That's not you need to take. It's highly correlated with the target. Okay, it's highly correlated with the target. Don't take it. That's why I had dropped. So our result coming here is how much these errors. MAE 0.39, MSC 0.22, RMSC 0.47. We'll go with the error. R2 is less. Got it. Next, I'm sharing you the code where you need to apply random forest regression. Kindly apply random forest regression and let me know how much score you are getting. Control V, Apply random forest regression. For pre-semester, if you include ISEC, then obviously R2 will be more. Okay, try random forest. I pasted the code here. Okay, let me try at my end also. Random forest regression. How much score is coming? Let's check. Random forest regression. Okay, please let me know at your end how much score it's coming if it's executed. I'm running on local machine, it may take time. And the algorithm is random forest with 200 estimators. That means 200 decision trees are there. It will take time to reply. Please let me know if you got the result. Okay, madam got point 0.1, point 0.01. Madam, less R2 again. MA is zero point 0.4, MSC is 0.23, RMSC is 0.48. Okay, errors are less. R2 is Mr. Venkat 0.89, I guess, because of pre GPA. If this much score you are getting, na, Mr. Venkat, it means that you have included pre GPA. Okay, if you are not including pre GPA, then madam got the result as I am under execution now. My code is under execution, and madam got the result over Kaggle, I guess. So, like, what's the not free? It's not free. It's pre GPA, pre GPA. This feature, it's present in your data. This one, let me show you again. This one, pre semester GPA. You are getting high score because of this only. Is showing correlationship with the target. Correlated with the target, least correlated among themselves. That's what I told. Okay, but not not as target is there, and same thing is present here. That's not what I expect. Okay, good correlation with the target is fine, but not 100% correlation with the target. Then target is here also and target is here also. Then what to predict? Everything will be matched from year to year. Okay, so good correlation with the target is fine, but not perfect correlation with the target. Okay, and if there is a perfect correlation with the target, then what is the sense of using these features? Because already you are having one feature which is perfectly correlated with the target, then do the prediction from this only. What's the sense of using these features then? Okay, you can only pick pre-semester GP and predict the post-semester. That's it, because both are 93% correlated. But I have dropped this pre-semester because the reason I already told. Okay, got it. How much score rest of the people? Okay, I got again the same thing which madam got. 0.48, 0.23, 0.40, 0.01, R2. This is what I got. Okay, ISEC also got the same thing. Can you please explain scaling again? Scaling is a technique which we are using here, that is standard scalar, and it is x minus nu upon sigma. That means value point minus mean of the entire column. All the entries take the mean, and this is the standard deviation. Standard deviation sigma. So find the mean, calculate the standard deviation. Okay, standard deviation is square root of variance. And what is variance? How far a distance from its mean. Sometimes we take the square. Okay, got it. This is standard scalar. We are applying that one. And scaling is mandatory in order to get the orientation of the data. All right. So we got this scores. Next, I do have another model which you can try after random forest is XGBoost. XGBoost regressor. Please try this one also. XGBoost regressor.
Sir, after removing the correlated features like you did one of post GPA,
Hmm.
so we want R to be high, R2 value to be high, or we want R2 value to be low.
We want R2 value to be good. Actually, like if it is point 0.8, zero point 0.9, then it's very interesting. Such scores are good scores. Point 0.8, zero point 0.9, zero point 0.7 is also fine. But if R2 is less, that means less variance is explained by the model. Means less distribution of the data is being explained by the model. However, we are getting errors. We are getting the errors which are less. We are recommending error as our primary metric. In general, let me clear you. In regression, error is the primary metric, not R2. Error is the primary
Okay, sir.
metric. Okay, so MSC is your primary metric, or RMSC is primary metric, or MAE is your primary metric. R2 we are calculating additionally. Got it.
Okay.
So, all right, sir. So, madam shared the score of XG boost, it is 0.04 R2. Anyways, errors are still less. Fine. Errors are still less. What about others? XG boost. XG boost. I've already pasted the code. Already pasted the code in the comment section. Please tell me how much score you are getting from the XG boost. I got one result from here for XG boost. Other people also. Hopefully, you will also get the same result as Madam did. One query. Like in Kaggle notebook, my line numbers are automatically updating. Yes, Madam, it will update automatically. Okay, it's not an issue. Okay. So Jobins are also got the same, like R2.03. Errors are less. Fine, sir. It's okay. Fine. Then after XG boost, I guess I applied CAD boost. Okay, no need to work on the CAD boost. Okay, okay, do it. CAD boost also perform. Control C, Control V, apply CAD boost also. And then later on, you can do the comparison between all these models. You can do the comparison of all these models. Control C, let me put it here, Control V. So kindly run these two cells. These two cells kindly run and tell me what results you are getting. Yes. Okay. Again, error is less. Fine. R2 is less. Fine, and that's okay. But errors are less. You can do the comparison also and identify which model is having the error, least error, which is having the less RMSC or MSC. That will be the good model for our analysis. So the point is clear. My target was post. My target was post GPA. GPA. I removed pre GPA in calculations. Why? Because these two are directly proportional to each other. And keeping pre GPA in my feature as a feature for training and predicting Y. Okay. So these are highly correlated with each other. If that's the case, 93% correlation they are showing. If that's the case, then automatically the pattern which is present in the target which I am expecting to identify, that's already present in my feature. Then obviously it will show high R2, 88%. Why variance is explained? Why variance is explained? Because you're already capturing the points which are present in the target. And how they are, what made them easily captured? Because of this person. Easily captured. But we removed that and then we find the error. And we are getting less errors. We are getting less errors. All right. Well, I will be sharing you this notebook, everyone. I will share you this notebook. It do have deep learning also present in it. This code have deep learning also present in. I will be mailing to you. It comprises of classification also. Okay, got it. So please run this entire code as an activity. Okay, because why I explain this particular coding? Next class, because in the upcoming classes, I will be talking about text. I'll be talking about images. So unless and until you don't know the basics, then how you are going to do the image classification by your side? Will likely to do the code in this way. You will be present live in the class, running the code. I'll be copy pasting here in the comment, and you are going to run the code. I will explain the concepts. You are going to run the code here. Understood? And this is our trial that how you perform. Got it? All right.